We are continuing with our review of trigonometry, which you should have done in grade 10 academic, focusing on sine law and cosine law for this lesson. Our learning goals, again, we're going to review sine law, cosine law, and then we are going to hopefully correctly choose the right formula and solve for angles or sides. So the formulae, which is plural for formula, or you could say formulas. We'll start with sine law. And really it's only one law, but I like to rearrange it into two different versions of the law, one for sides and one for angles. Just makes life easier when you're solving these if you do this. So if we start with sides, A over sine A equals B over sine B. Don't get rattled by the letters if the triangle doesn't have A and B in it, right? Doesn't matter. But what you should notice is the patterns. So when you're looking for a side length, you have side lengths on top. How do you know those are side lengths? Anything. So remember, going back to labeling a triangle properly, all side lengths get labeled with a small or lowercase letter. Then on the bottom of the ratios, you have the capital letters, which represent angles. So side lengths, sides on top, angles on bottom. Also within each ratio, you're going to notice A goes with sine A and B goes with sine B. So you should never have A's and B's or whatever the letters happen to be mixed together. For angles, basically the same, but flipped. So you start with the angles on top. Sine A over A equals sine B over B. Now, how do you know when to use sine law? Technically speaking, sine law and cosine law can be used on 90-degree triangles. I would like you to try to focus on doing SOHCAHTOA for those, but you could use sine law and cosine law on 90s. The converse is not true though. You cannot use SOHCAHTOA or Pythagorean theorem on non-90s. So we're going to do sine law and cosine law for non-90-degree triangles. How do you know to do sine law though? You need a complete letter or a complete ratio. So in other words, if I was just to draw a very quick triangle here, you need to have a complete ratio, meaning you need to have an angle and a side completely across from each other. If you have both of those pieces of information, you should be able to solve any non-90 triangle. So you need a complete letter, or if you want to think of it as complete ratio. So that's sine law. Cosine law. Same thing, it's really only one law, but I like to split the formula up into two just for ease. And normally you'd have to memorize these. However, you have the benefit of having these formulas in front of you, so it's not too bad. So c squared, for side, c squared equals a squared plus b squared minus 2ab cos c. Again, don't get rattled by the letters. It could be any letter, it could be x, y, z. The pattern, though, that you need to realize is that this side you're looking for always has to match this angle. From there, it doesn't matter what you call A or B. For angles, and just like the sine law for angles, it's just a rearrangement of that formula, but I'll give it to you. Cos C equals a squared plus b squared minus c squared all over 2ab. Again, the letters don't matter. All that matters is you picking out the patterning, which if you're looking for angle C, small c has to be on the back end being subtracted. If you were looking for angle A, side A would have to be on the back end being subtracted, and all the letters would just kind of switch places. Now, how do you know to use cosine law? So for cosine law, again, it's for a non-90 triangle. You need to have two sides and a contained angle. So what that means is I got a side, I got a side, and I got an angle in between them. So you're looking for this kind of situation. Two sides and an angle contained between those two sides. And you're going to notice that I don't have a complete letter ratio. I don't have a side length and an angle right across from it. So you'd use it in that instance for side lengths, or cosine law is actually the only formula you can use when you have no angles. Which, if you look at your formula for angles for cosine law, it involves all three sides and you're looking for an angle. So you cannot use any other formula except for cosine law when you have no sides given. So make sure you have those formulas in front of you. We're going to use them and just do some examples. Example number 1, solve for b to 1 decimal place. So if you need to, pause the video, make a quick sketch of that diagram. For the record, so you know, diagrams are never going to be to scale. So if you're looking at something and you're like, that doesn't look like it's 30 degrees, it's got to be way bigger than 30. A lot of these questions, it's just a stock diagram and then I change the numbers. So just so you're aware, if you see a question in a lesson or in a textbook or in a handout or on your test, if it looks like it's like really close to 90 and ends up being 20, let's say, don't panic because, again, the diagrams aren't going to be to scale. Trust in your mathematical knowledge. First thing you should do, I gave you the labels of all the angles. You should label all the side lengths. So if we start with capital A, angle A, right across from it below is side A, small a. Capital B, right across from it, side B, capital C, right across from it, small c. What I like to do is make a little chart like this. And start with the side lengths, and then write the angles, and fill in what you know. So I don't know what angle A, or side A is. It's asking me to solve for B, so there's my question mark. Side C is 26 centimeters, okay. Capital A is 72. Capital B, I don't know. Capital C is 47. Do I have a complete letter? I definitely do. I have this. If you have both pieces of information like that side by side, that is your indicator to use sine law. If you're looking at your picture, you have an angle right across from a side. That is your visual cue from the picture to use sine law. So we're looking for a side, right? We know we're looking for a side because it's a lowercase b, so let's start there. B over sine b equals. Now what it equals is what you drew the box around, or the letter that you have the complete ratio. You have both pieces of information, which in this case is c. So c over sine c. Then from there you play match game. So b, I don't know. Sine, I don't know capital B. We'll come back to that in a second. Side C is 26, capital C is 47. Now before I come back to our little one common error at this point. Sometimes students write 26 over 47. They forgot the sign. It's called sine law for a reason. It has to have sine in it. So don't forget about that. Don't just write 26 over 47. Now we run into a problem. I actually have two unknowns. I don't know what side B is, and I don't know what angle B is. I do have an easy way, though, to find angle B. Does anybody know how you could find angle B? Shout it out. Angle B is, if you know the other two angles, how many degrees are there in a triangle? Well, there's 180. So if I want to figure out what B is just 180 minus 72 minus 47, which if you do some quick math, 180 minus 72 minus 47, we should get 61 degrees. So there's my angle B. So now my uh-oh goes away. Sine 61. How do I solve that? That's just a ratio question. I want to get B by itself. So how do I get that sine 61 off the bottom? I cross multiply. So B equals 26 times. Now you don't have to write the times because your calculator will just do it automatically for you. So you could just write 26 sine 61 like that over sine 47. And this says round to 1 decimal place. And you can literally type that in your calculator just like you see it. Now before you begin, make sure when you turn your calculator on, it's in degree mode and not radian or gradient mode. Now, normally I'd be able to help you in class with fixing your calculator if it's not in degree mode. That's going to be tough virtually. So what I'm going to say is type this into your calculator just like you see it or like you hear it from me. So 26 sine 61 divided by sine 47 equals. Right now on your screen, if we round, you should be seeing 31.093 blah, blah, blah. If we round to 1 decimal place, that is 31.1 centimeters. If you are not looking at that on your screen, retype it in, and if you still don't get that answer, that probably means you are not in degree mode. So you're going to want to reset your calculator. And if you're still having trouble with it, if you send me pictures of your actual calculator, of the front of it with all the buttons, I could probably walk you through how to get it into degree mode or how to reset it, because the default for any calculator is degree mode. So there's sine law, looking for a side length. Example number 2, we are going to solve for r to 1 decimal place. Your first step should be label your sides. So that's side P, side R, side Q. Remember, they always go, the letters go across from the angles. And then I like to make a little chart. Fill in my information. I don't know side P. Side Q is 20 meters. Side R is 17 meters. Capital P, I don't know. Capital Q is 63, and capital R is what I'm looking for. Do you have a complete letter? Yeah, I got Q, both pieces of information. That is our indicator to use sine law. Visually, I got both pieces of information right across from each other in my triangle. Sine law for angles. So we're going to start with what we're looking for first, sine R over R equals. The other ratio is what you drew the box around, or the ratio that you have both information, or both pieces of information, which is Q. Fill everything in, sine R over 17 equals, don't forget about the sine, don't just write 63, so sine 63 degrees over side Q is 20. Get that 17 off the bottom, cross multiply. Sine R equals 17 sine 63 over 20. Now, if you just type that in, 17 sine 63 divided by 20, you should be looking at 0.757. That is not how many degrees that is, and hopefully that sends some alarm bells for some of you. Clearly, it's not 0.757 degrees. So you cannot forget that when you are solving for an angle, you have to use the inverse. So remember, to get to the inverse button, you either on your calculator have to hit shift or second function, typically in the top left-hand corner of your calculator. So to show your steps on, say, your test, you would write r equals sine inverse of 17 sine 63 over 20 and put it in brackets. Don't ever hit clear. Don't round these numbers. Rounding does make a difference when it comes to trig. So what you should do is clear your calculator right now. Type in shift or second function. So to get to sine inverse, open bracket. Most of you should be looking at a scientific calculator that has brackets on it. So you open a bracket, then type in 17 sine 63 divided by 20, close bracket, hit equals. And we said 1 decimal place, you should be looking at 49.23, so 49.2 degrees. If entering it all in one step is too much for you, this is a bit more complicated, but you could type in 17 sine 63 divided by 20 to get that decimal again, 0.757 blah blah blah. Don't round, don't clear. At this point, leave it on your screen and just type in shift or second function, sine inverse, and most of you have an A and S button around the equal sign possibly. That just stands for the answer, so sine inverse of your answer. If you hit that button that says A and S, hit equals, you'll get 49.2 degrees. Again, for your test, it's a good idea to show me as many steps and as much work as possible to prove that you know what you're doing. And if you're struggling with these steps, make sure you let me know so I can help you. You can even remember log into Teams to one of the team help session every day between 10:30 and 1:30, and you can turn your camera on and you could show me your calculator and I could try to help walk you through it that way as well. Number 3, solve for A to 1 decimal place. Step number 1, label our sides. Across from capital A, side A, capital B across side B, and side C across from capital C. Again, I do like to make this little chart. It's a good habit to get into. Just another way to give you a visual cue of what to do. I'm looking for A. B is 5. C is 4. A is 63 degrees. I don't know B and I don't know C. And I don't have an easy way to get B or C. I can't do my little 180 minus trick, right? So if you see that in your chart and you don't have a complete letter, that is your cue, right? We don't have a complete letter. That's our cue to use cosine law. Or if you look visually, we have two sides and a contained angle. We have the angle in between two sides. That's cosine law. So a squared equals b squared plus c squared minus 2bc times cos A. Fill in all your info. Now, if you're wondering, do I have to type in the formula or do I have to write the formula every single time on my test? The quick answer is no. Again, the more steps you show me, so that way if you happen to write that formula wrong, I can still follow your wrong work all the way through and I understand why you did it wrong because you wrote the wrong formula down. If you don't write that and you happen to write the formula wrong, I don't know why you sub numbers into where and it makes it harder for me to give you as many part marks. So you don't have to write the formula if you're confident in what you're doing. You definitely need to show me at minimum the number of steps that I show you in the lesson though, which would be subbing in these numbers. That can be entered all in one step. So everyone could type in 5 squared plus 4 squared minus 2 bracket 5 close bracket open bracket 4 close bracket cos 63. Hit equals. Now I'm just to write my steps, I'm going to write 22.84. Now there's more than that number there's more than those numbers on the calculator, but I'm not going to hit clear. If you did hit clear, it's okay, but I'm just going to leave it on my screen. Does that mean though that side A is 22.84 meters? Seems, again, diagrams aren't to scale, but when the other two sides are 4 and 5, seems a little bit off that it would be 22. Possible. Do not forget, this formula isn't A equals, it's A squared. So what you do to get rid of A squared is square root. And if you're wondering why isn't he writing plus or minus in front of the square root, we're talking about side lengths. You can't have a negative side length. But I like where your head's at, if that's what you're thinking. Now, if you didn't clear everything off your screen, you could right now hit the square root and your answer button, hit equals, we round to 1 decimal place. You should be looking at 4.779, which rounds to 4.8 meters. Again, these are not to scale. So if you're thinking, well, side A looks longer than B and C, but it's, the other one of them is 5 and this 4.8, don't worry about it. Trust in your math. And last but not least, we are going to solve for E to 1 decimal place. Step number 1, copy down your triangle, label your sides, that side E, that side F, that side D. Now we could make our chart for this. I'm not even going to bother making the chart because I have no angles. And it should be instantaneously, like snap my fingers, you see 3 sides, no angles, cosine law for angles. So now this is just a matter of setting this up. Cos of the angle I'm looking for equals, and if it helps you to remember the pattern, our pattern was whatever this capital letter was, we would subtract the small letter on the other side. So minus E squared. And then it would be the other two sides, doesn't even matter what order you put them in, D squared plus F squared, let's say, over 2dF. If we fill our information in, that's 17 squared plus F is 15 squared minus E, which is 12 squared over 2 times 17 times 15. This is a bit tougher to do all in one step. I mean, you are welcome to do it all in one step. If you do that, you need to treat the top as one and the bottom as one. So you'd have to add a separate set of brackets around the top and a separate set of brackets around the bottom. I'm going to say for simplification, especially virtually, just do the top separate from the bottom. So right now, everyone type in 17 squared plus 15 squared minus 12 squared. Hit equals, you should get 370. Then type in 2 times 17 times 15. You should get 510. Don't forget we're looking for an angle, which means we have to use inverse, so cos inverse. Don't forget this is cosine law. Sometimes people will write sine inverse, and then bracket 370 over 510. So shift, or second function, cos, open bracket, 370 divided by 510, close bracket, hit equals, and 1 decimal place, you should be looking at 43.49, blah, blah, blah. 1 decimal place is 43.5 degrees. So that's it. Hopefully that's a good rundown for you for sine law, cosine law. Your seat work is the handout that I have attached to this lesson on D2L. And then your next lesson, next 2 lessons are continuing to review the properties, the formulas that you've just learned, so Katoa, sine law, cosine law, but applying them to 2-dimensional problems and then 3-dimensional problems. That's it. Thanks for listening. Talk soon.